Yep, we're still in two-dimensional collisions. So there's actually only two sections in this chapter. So we're getting near the end, but we're going to try to push it out until early, mid next week. Okay, so as we go through, here's what we looked at last class. And we had in two dimensions, we have to deal with the x component and the y component and compare it, use that to get the final. Now, yesterday we saw an example that has a ton of work showing, but all of this makes it look really complex. There is a single theorem that we can make use of to make sense of this. What's the theorem that we seemingly used yesterday? So I guess there's more than one. It's when I say theorem, I think like pure math stuff. So that is a good, it's like an idea of a theorem. It's a law in physics. But I like that. We use conservation of momentum for sure. What is this? What's happening up here? Or here? Old Pythagoras, he hooks it up again. Okay, so we did this problem yesterday. We ended with using SOHCAHTOA to work out our bearing. Remember that as we're working on this angle, we have to pay really careful attention to where it actually spits out, because if we're in quadrant 2 and or quadrant 3, I'm sorry, down here. I'll just draw it up here. What am I doing? If we're in quadrant 3 and I were to work out a tangent of something, down here, it's only going to give me this angle. So we need to either give a bearing or do the little bit extra to get the real angle in standard position. So always be mindful of that. Let's do another problem together. Cool. So this one, a little bit harder, but not a threat. So just like we did the other day, don't believe them. Okay, you do not have to write down this whole problem. This is example. This is number 29 on page 251. If you want to just have that in your notes. 29, page 251, and I'll get this up on the board, and we're going to work through it. So, example number 29, page 251. If you want to read the problem in your book, you're welcome. Holy big. Okay, I'm going to give us a second. I lied, I'll just read through it. But you guys are going to help me through this whole problem. And there's some pieces in here that, as long as we keep stuff straight, easy problem. There's no challenge. Okay, so we have a stationary billiard ball with a mass, and it's struck by an identical one that's already moving. Afterward, the second ball, so the one that was at rest, moves 60 degrees to the left of its original direction, and the stationary one moves 30 degrees to the right. We want to find the velocity of both of the billiard balls after the collision. Would a picture be helpful? Probably. Now, here's the cool thing about it. Do we ever specify what direction stuff is traveling in initially? Like, I tell you which way the balls are like pushed after the end, but do we ever know which direction stuff is going? Now, our reference frame, and you don't have to draw this, I just want to talk about it. Is it possible that if we try to set this up, and again, do not draw this yet, here's a pool table, I'm not going to draw all the pockets. Maybe I'm shooting the initial ball like this. Is that possible? Now, even if it's possible, I think, and I hope you agree with me, I'm just going to draw it like this. If I do it like this, it's kind of ugly mathematically, because if I try to place this like on a system, it gets ugly and gross, right? Because we don't have that angle. What could I do to make that so much nicer? Rephrasing, is my coordinate system that I use set in stone? Do I get to just pick it? So wouldn't it be easier to just imagine it's doing something like this instead? And then holy cow, if we start the initial one along the positive x-axis, then everything else works out pretty nicely. So let's sketch a small picture of this. We have a original ball, and we're going to pick letters here. I used A and B. Barsega, I made a comment on your homework. When you're doing some stuff, you switch to V1 and V2. I have no issue with that. A and B or 1 and 2, doesn't matter what you use, so long as you're still using initial and final stuff, okay? I think, honestly, for me, it's more natural to use 1 and 2, unless we have a bunch of stuff going on. I'm going to call this ball A. Okay, now ball A is moving, and it's moving like this. Okay, and it's going to strike ball B that looks like maybe it's right here. So very similar to the example that we set up. After it strikes, we're told that ball A continues to up here, and ball B, and I'm going to scroll up so I can see the numbers. Oh, and I'm backward. Check it out. The second ball moves 60 degrees to the left. Never mind. So I'm just going to make that B. And the first ball moves 30 degrees to the right. So there's ball A. And my picture, can you guys tell, is a little wonky? Does it matter that it's wonky? Cool. Are you looking at, like, how did it work? Yeah. Yep, so that's the wonkiness that I'm referring to.
Isn't A supposed to go up?
There we go. Nope. The first ball, the second ball moves 60 degrees to the left, which if I'm traveling, walking this way, left is here. So B does go to the left. Okay, now, as I'm looking at this, I see here's what happens, and I'm going to sketch out a nice little plane here. So here is just a continuation. This is like my x-axis that we're imagining. What's this angle? Ball B. The second ball, it went left. At what angle? 60 degrees. Now, how would you label this? Because I can't just call it theta because we have two of them. Theta sub B. Okay, so that is 60 degrees. And this one down here, much smaller, I'll call this theta sub A. And that's how many degrees? 30 degrees. Okay, just the picture is going to help a ton to make sense of this stuff. Now, when I did this problem initially, I didn't set it up like this. I set it up so it did this, and then my math had to be fancier because I still worked from the x-axis and measured these angles when I did it, but it was a waste of time and energy for me to do that. This is the easier way just to set it up initially. Okay, same answer. Cool. All right, this is what's going on in my picture. I feel okay with this. Help me out with the knowns, because we need to be able to write them all. No. I'm going to keep those up. Yeah, my glasses aren't seeming to work today. I'm really struggling to read. Huggins, can you hook it up and give me one of the knowns?
Mass of ball, because they're the same.
Ooh, I like it. So I'm going to say MA equals MB. And then for simplicity's sake, since they're the same, can we just call it M? Like it's the only mass that we have, right? If you want to use A and B, we can. But because they're the same, we don't need the subscript. Everybody okay with that idea? And what is a mass? 0.17 kilograms. Thank you, Riley. Okay, other things that I know, you know, we know. Fern, hook it up. Something else. All right, so velocity of A initially is 4 meters per second. I agree with you. What about B? 0, because it's at rest. Cool. And then I have 1 or 2 more little things that we can include. Any other information given here? Hey, I know the angles. So we have theta A was 60 degrees. And then I'm going to make a mistake, and I want you guys to tell me what is that mistake. And it's already happened. It just happened. One more time? Okay, so that was 2 mistakes on total accident. That should be the 30, right? All right. So let's see. B, that was not the accident I meant to make. That one's 60 degrees. I'm going to make another mistake real quick. Can you tell me what my mistake was? They're not on the same what? Negative. Angle A goes downward in our picture. That's negative. Cool. Negative 30 degrees on A. All right, so we have all of this stuff going on, and there's a lot of it. Okay, couple things as we're trying to make sense of this. We'll just indicate what I'm trying to find, and I can't see my words anymore, but I know that it's the final velocity of A and the final velocity of B. These are the things that VB final. There we go. All right, this is what we're after. Now, the pictures help a ton. I suggest we do one more small picture just without the balls and stuff to try to make sense of it. Because all that we worry about, it's not like the ball that itself is conserved, although it is, but we're looking at conservation of momentum. Do all of these pieces rather have momentum to them? Like, especially after the collision. So, here's what I want us to think about as we're setting it up. Initially, we have a momentum, and we're going to draw another picture real quick. We have some initial momentum happening on A, right? And it's going completely this direction. Do we have enough information to calculate it if we want it? We do. Okay, beyond that, we are going to see a little bit of overlap with the pre-calc stuff in the vectors. Here's my initial momentum. Now, in this situation, are there also components that are going to spit out? And what I mean by that is if we look at this, we're going to write out some work as well, and we'll come back. I'll leave space so I can add to this picture as we get it. All right. I'm going to start us off, and I'm going to have us do something a little bit differently. I want you to talk with each other, see if you can find for me the final momentum of B or A. Now, there is some triggy stuff going on here. We're going to see how much trig can we relate to here. I'm going to give you guys like a minute, and then we'll come back together and hear ideas, okay? Okay. So not a lot of conversation. I do see a lot of like thumbing through the pages of your notes and book, which I love. I want you guys to help me out with one other piece here. Conservation of momentum says the initial momentum is equal to the what? Final. So if we just start to write it out, because whether you know how to do this problem or not, conservation of momentum is where we're at, and this is what we're going to use to solve the problem. Do you agree that all of the momentum of A is all that we have initially? This is all of my initial momentum because nothing else is moving. What are the two pieces that go into the final momentum at the end? Like, where does all of the movement from A go to? A and B. So just without writing anything else, do you agree that it's whatever A does down in this direction plus whatever B does in the other direction? These are the only momentums that we have. Everybody on board here still? Okay, now, if we think about what's going on, I want to make a really important observation. This statement is obviously true, I hope. But here's the really cool thing. Momentum, does it have a size or a magnitude? Does it have a direction? So we and I elected early on to not make you guys write these symbols all year long, but don't add these. If it has a direction and a magnitude, what is it really? Angel quietly whispered it. She said, one more time. Sorry, my eyes made me make you doubt. So velocity, they do have velocity, but do you agree that they're both, or all three of these are these? Like, they have to be vectors, right? Like, both size and direction. Now, this is like the perfect overlap right now, and it's awesome. How do we add vectors? So you could do the components. We could do it pure mathematically. But if I want to think about it graphically, let's try this out. Da, da, da. We add tip to tail. So check it out. If I just eyeball these out, I think that I have the velocity of A goes like this. Or sorry, the momentum of A goes like this, right? This is momentum of A final. And I said I was going to do it here, but I'm apparently doing it. I'll do it up here. Let me move this out of the way. The velocity. All right, not going to say velocity and place momentum again. It is not going to happen starting now. The momentum of A initially does this, and it's a vector. Everybody on board? I'm going to add to this, at the tip, I'm going to add B, which looks something like this. Everybody's still on board. We just tip to tail. Now I have a new vector hiding in here. Dude, what does this vector represent? Based on this statement, if I take vector A for the momentum of A plus vector B, it adds up to this guy. What did we just write that was? Oh my gosh, it's the initial of A. Now, I happen to have a lovely triangle that's just hanging out here, but I think I even know a little bit more to it. On this triangle, because A was originally going in this direction, and because we sketched our picture so nicely, can anybody tell me this angle? What direction did A travel at? 30 degrees. Now it was negative 30, but it's 30 degrees here. And what about B? 60 degrees. What's this angle have to be? Hey, my gosh, it's a right triangle. By sketching it out and just writing conservation, we, I think, have a way into this problem. Talking with your neighbors, we're going to do the same thing. Another little push. We've got a lovely right triangle to deal with. Maybe, just maybe, there is some trig work that's going to happen here and we can solve it. I want you guys to make sure that you make use of this muscle that runs across here, your diaphragm. When you flex your diaphragm, it changes the pressure in your chest and it draws air down in. And then when you relax it, air is pushed out. But the really cool thing is that if you change the shape of your mouth and the frequency of the vibrations in your throat, you can actually communicate the ideas with the people next to you. Phenomenal human ability. Cool. Talk out there. I'm going to give you 2 or 3 minutes. Let's see where we wind up. I'm looking for ideas. All right. Looking at this, I want to focus on this triangle. If you want the number in, I wouldn't have it, but could we calculate this? Do you want the number first before we do calculations? Or before we do the algebra? Okay, that's like more natural for people. I'm going to do one line here just so we can get a number in here so it feels a little bit more natural. The initial momentum of A. What was its initial velocity? So we have 4 meters per second. And we're going to multiply this by, what was its mass? 0.17. And let's see, that's 3264. 3468, I'm sorry. 0.68 kilogram meters per second. Okay. Now, just to make sense of what we've done, like this is just to get a number in front of us. If I redraw this triangle without the arrows, here it is. We still know that this is 30. We know that this is 60. And now we know that this side that's opposite from my right triangle is 0.68. Okay. Now, we are trying to find this side and this side, because if we can find their momentums, we can in turn get the velocities out of it, because we just have to divide by the mass. Okay. Now that we have this up, it doesn't matter which one we start with. Do you want to try to solve for B or A? There's not a right choice. B, sure. So if we solve for B, and did I just go with the opposite of what you said? Okay, A it is. All right, so I'm going to highlight this segment. This is what we're after. Cool. There's a triangle on the board, and it's special. What's special about this triangle? Maybe there's... Ooh, it's right. I was going to say there's lots of things, but that's the one that I was looking for. Okay. Gosh. Well, if I go from this 30 degrees, this is which side? If this is where I'm going from, adjacent. And what's the other side that we know? The hypotenuse. So let's play a little bit of trig game for just a minute. Adjacent and hypotenuse. Cosine, right? So ca. All right. So here we go. Cosine of, what's that angle we're going from? 30 degrees is equal to, what was the opposite? Or adjacent, I'm sorry. Rho A over, what's the hypotenuse? 0.68. Now this is killing me to do it, but I will write the number. I really want to write rho F, That's fine. Or row AI. Cool. Can we solve for row A? So check it out. Can we do it without a calculator, you think? Not to get a real nice number, but what would you do to solve for the momentum of A? So time out. We'll get there, but we're here first. I'm going to multiply by 0.68. I think it's still cosine, isn't it? Okay. But we're good. We're going to get through it. Cosine of 30 degrees. My calculator will tell me. What is it? Don't look. I want you to tell me. 30 degrees is a nice number. Here we are at 0. 30 degrees. More right or more up? More right, which means which is the option? On the unit circle. Root 3 over 2. Now I can't multiply by root 3 over 2 really nicely. So I'm okay with you guys approximating it here, but I wanted to make sure we had the trig part. 68 or 0.68 cos of 30. I have no idea what this is. Say it again? 0.59. Can somebody second that? Okay. Kilogram meters per second. So check it out. We have 0.59 down here. Cool. What else do we need? Do we want to do B first, or do we want to get part of our answer out of this problem? Since I'm already in green, I think we should just stick with that. What am I trying to find? So if I have momentum of A, and I'm going to write out the general formula first, the momentum of A final is what times what? Mass times the final velocity of A. Notice, we just found this. We know this. Can we find the velocity of A? Okay, hook it up. I'm going to write my answer over right here. Velocity of A final. I just don't have the number. 0.68 over 0.69. 0.59, I'm sorry. What? It should 100% be 0.17. I'm so sorry. Now I'm going to play the unit game real quick. Kilogram meters per second was there. This was in kilograms. They gone. And I'm left in velocity, which is a good sign. What's up? Did I do something weird? What should this be? Notice what happened. I looked up to get this number, right? But I copied this number. Would I have caught that mistake if we didn't catch it just now? I bet I would have, and I'll tell you where. I'd like to think that I would have. What should that have been instead of 0.68? 59, right? Which is 3.5? Pretty close to that? Cool. Check it out. 3.5 meters per second. I'm going to star this. I'll put my final answers over here within context, but I have half of it. Okay. By drawing this out and getting my right triangle, the whole problem opens itself up. I want you guys to find me B using the method of your choice. So Sean claims 2. Using the method of your choice, I want you to verify. Sean, I don't disagree with you, but I want to make sure that we can all get it through the work rather than just the answer. Right. Which one did you do? You did sign, okay. What was your other option? To find it. So you could, and you could use any trig function at this point, right? Or alternatively, Pythagorean theorem. So for this, you have a bunch of options. And if I'm talking and you don't need help, you can tell me that and I can walk away. But if you're struggling with study, this would be great. So we know two sides of this triangle. You can either try to use this angle 60 and work out your trig stuff, or we know two of the three sides of the right triangle. That would be this. Okay. Fern, trig or Pythagorean theorem? Trig. You two, trig or Pythagorean theorem? Trig. Trig, Delilah Trig. Okay, if I'm trying to do this in trig way, and I'm just going to catch up with you guys, here it is. That's what we're looking for. How would you find this red one? Which angle could we go from? You could go from 30 still, absolutely. Or we could go from the 60. But if we want to go from the 30, I'm cool with that. So 30, this is opposite, right? And we still have the hypotenuse. Which trig function is that? So we see that the sine of 30 degrees, this one's much nicer, we don't need a calculator this time, equals what over what? Opposite is here, over, so 0.68, and let's check it out. 0.68 times the sine of 30 is apparently equal to this momentum in B. Okay, I claimed we don't need a calculator. Here we are, 0 degrees, 30 degrees. I'm way more right than I am up. What's the y value here? 1/2. What's half of 68? So check it out. 0.34 kilogram meters per second is our momentum. Are we done? Not quite. We have one last little step. If I write, I'm not going to write out the formula again, but I know that the momentum is just mass times velocity, right? So check it out. mvb this time equals, we just decided 0.34. I'm not going to mistake it this time. What should we divide by? The mass, which is 0.17. And these all work out so handy. 0.34 over 0.17. What's the velocity of B? 2. Now, where I claimed, and I'll tell you, I did get this problem wrong the very first time that I did it, because I did a similar mistake. I don't remember exactly what it was, but I had the wrong answer, and I did find it. Because when I get to this point, I can take these values and I can make sure that my Pythagorean theorem works out with my momentums. If it doesn't, I have a mistake. If it does, I'm feeling pretty good about it. How should we express our answer? And I know that on quizzes and tests, I'm way more hardcore about this, but the velocity of what? So ball A, and I'm going to write the lazy form of this, has VF equal to what? 3.5 meters per second. And ball B has a final velocity of 2 meters per second. So it didn't. Because the really cool part about this is that, notice, these are in these directions. So if we check the momentum, and this is what we just did, we see in the x direction we still have the same amount of momentum. If we were to take the y directions and we'd use that negative angle like we had, they cancel out. Cool. We have everything exactly where it is when we started, same amount of energy. We have just changed. It feels like we've gained, but we haven't. Okay, cool. These problems, that one honestly is the challenge. It was like the hardest one that we have. You guys have 15 minutes. I want you to do 2 problems for me. So those 2 problems that I want you to do, and it might actually be 3 problems, so I lied right to your faces. 3 problems, 14 minutes. We gonna get it. We have waiting for us homework 9.2.2, I believe. And we're gonna find this on page 250. And I want you guys to do problems 25 through 28. I cannot stress enough. Would this have been doable without the picture? Okay, so literally we could have done it without the picture. Was it a million times easier if we have the picture? For sure. All right, so to hook up people who are traveling, and hopefully they are watching this, here, if you guys want it, is the assignment. I will keep this up on the board for a couple minutes. I can't get it to, there we go. Did I say 25 through 28? I definitely meant 26 through 28. 26 through 28. And I will fix that here. 26 through 28. Baller. I will keep this up on the screen for a few minutes. I want you guys to get started. More similar to the first one than the second, just so you're aware. Cool.